Everyone wants their computer to run fast, the internet to act faster, and productivity to be at the top notch level. Yes, we are playing need for speed here. If we expect to multitask as well as want instantaneous results, we believe that computer processor speed or CPU speed matters. Well, does it matter, or is it the way companies try to sell newer generation processors? To know if it is utterly meaningless or makes some sense, let us know what is gigahertz in CPU and if the clock speed matters. Let's quickly look at the fact that how many clock cycles a CPU experiences each second. For example, a processor rated at 4 GHz or megahertz can handle a billion more cycles per second than one rated at 3. But what is gigahertz? It is a measure of frequency equivalent to 1000 million cycles per second. In simple words, it is the rate at which a processor executes a task. The higher the number, faster processing it is. But with the advances in technology, the processor chip can now do more with less. To make things clear, let us take an example of a runner. The CPU clock cycles per second, measured in gigahertz, can be thought of as the number of steps a runner takes in 1 second. But this doesn't mean more the number of steps per second faster the runner is. There are chances that the runner takes shorter steps. This means the amount of information processed in one cycle is the same for each generation for a core. Generation means i3 third generation or i3 fourth generation. Thus, an i7 7th generation at 2.4 GHz will perform better than an i3 at 3.5 GHz. Coming back to the topic in hand, CPU gigahertz matters when the number of instructions per clock cycle and pipeline efficiency varies. Even the individual CPU models from a single brand clock speed can end up being deceiving. Alongside processing the number of instructions per clock cycle, CPUs also need to be able to read ahead on the page, so to speak, to work efficiency. I mean, you expect your PC to show you the right thing as soon as you give a command before someone else gives some other command. To achieve this, CPUs are designed to examine out-of-order instructions and make sure that they are executed such that they don't interfere with other parts of the program. Alongside this, other factors tie into the performance as well, like the type of RAM, different types and amounts of cache memory, super fast memory that stores small pieces of data that the CPU thinks it will need. Finally, if you are working on CPU-intensive tasks like video encoding or file compression having many cores, then gigahertz to spread the workload and crunch more data in parallel can speed things up more than a clock speed. This doesn't mean clock speed should be completely ignored. If that would have been the case, there wouldn't be overclockers and overclocking apps trying to squeeze as many megahertz as they can out of their chips. To know more about it, you can read an in-depth post we recently covered. The link is given in the description box. With that being said, what do you think? Does gigahertz matters or not? Yes, it does. But it shouldn't be a huge factor in your buying decisions. Just like you probably wouldn't buy a car based on how many cup holders it has unless you use them. Besides gigahertz, there are quite a few things that matter when talking about performance. IPC, instructions per cycle. Instructions a CPU can perform in a clock cycle. The cache memory, size and speed. The bandwidth, the amount of data CPU can exchange at once and how fast it can do that. Cores and threads. Essentially, each thread can handle a different task. The more threads your CPU can handle at once, the faster it can finish a certain task. CPUs with more cores are more efficient than those with fewer. Dual-core or two-core processors are common, but processors with 4 cores, also called quad-core processors, for instance, 8th generation Intel Core TM processors are better. But to be quite honest, these aspects don't matter for an end user such as yourself because no one explains these things. Hence, when buying a PC or checking the performance instead of only focusing on gigahertz, pay attention to other features too. This will help know how fast each processing will be. Now that we know about the CPU, let us talk a bit about the graphics processing unit, GPU, the part of the computer system considered important for PC gaming. What is a GPU and do we need both CPU and GPU or is one enough? To put it simply, both the CPU and GPU are important in their own right. A GPU is a processor made up of many smaller and specialized cores, while a CPU is constructed from millions of transistors and can have multiple processing cores. It is essential for all modern computing systems as it executes the commands and processes needed for your computer and operating system. Moreover, a CPU determines how fast programs can run, from surfing the web to building spreadsheets. Both the central processing unit CPU and the graphics processing unit GPU have very different roles. CPU versus GPU. CPU stands for Central Processing Unit. GPU stands for Graphics Processing Unit. Several cores, many cores. Low latency, high throughput. Good for serial processing, good for parallel processing. Can do a handful of operations at once. Can do thousands of operations at once. CPU consumes or needs more memory than GPU. The speed of the CPU is less than the GPU's speed and they aren't suitable for parallel instruction processing. CPUs emphasize low latency while GPU focuses on high output. CPU has powerful cores compared to GPU. CPU is composed of just a few cores with lots of cache memory to handle a few software threads at a time. In contrast, a GPU is composed of hundreds of cores to handle thousands of threads simultaneously. GPUs deliver the Once-Esoteric technology of parallel computing. The CPU is suited to a wide variety of workloads, especially those for which latency or per-core performance is important. GPUs specialize in accelerating specific 3D rendering tasks. This must make you wonder whether you should upgrade your GPU or CPU. In a perfect world, you should simply buy the best of both. Unfortunately, budget constraints make you choose one. However, if you are a hardcore gamer and want to run the most power-hungry AAA games, and more importantly, you can afford the extremely high prices, it might make even more sense to go with the premium options in either CPU or GPU. On the CPU side, one of the most powerful Intel processors on the market today is the Intel Core i9 series. And if you have got or are planning a GPU, buy a 4K ultra high definition UHD monitor. GPUs are expensive, so if you are on a more stringent budget, then stick to the CPU. Also, if you spend too much on the GPU without paying attention to the CPU, your gameplay might suffer from lower frame rates per second. If you like fast-paced games such as first-person shooters, a CPU upgrade is best, while if you play online open world games, go with a GPU upgrade. We hope we made our point, and with this, I, Shivani, is saying goodbye with a promise to meet you next week Friday with another interesting topic. Do give a thumbs up if you like the video and subscribe to our channel to never miss out on our latest videos. Do share your opinion in the comments below.